So the second test we want to talk about is testing with Ferlin solution. So of course, when we say Ferlin solution, it's an alkaline solution that contain copper 2 ions. So Ferlin solution is what? An alkaline solution that contain Cu2 plus copper 2 ion. And in that reaction that we want to talk about very soon, copper 2 ion will act as an oxidizing agent. So, of course, if copper 2 ion acts as an oxidizing agent, so it means our aldehyde will act as the reducing agent. So it's going to be something like this, Cu2 plus is going to be the oxidizing agent reacting with the aldehyde. So aldehyde will be the reducing agent. So of course, when the copper 2 ion, when it oxidizes the aldehyde, so it means we are going to have carboxylic acid. So it's going to give us COOH. So it gives us carboxylic acid. So the carboxylic acid, of course, if this one is a reducing agent, so it means if the aldehyde if the copper 2 ion oxidizes aldehyde to carboxylic acid, aldehyde will also do something on the copper 2 ion. So it will reduce copper 2 ion to copper 1 ion. So from copper 2 to copper 1, and from aldehyde to carboxylic acid. So what is going to be the observation in that regard? Of course, we know that copper 2 ion is a solution that contains copper 2 ion is blue. So it's going to be blue solution. So solution that contains copper 2 ion is a blue solution. But when this one gets when it gets reduced, we're going to have copper 1 ion. But that copper 1 ion is not going to be in form of ion, in form of aqueous. It will come together with with oxygen. So this one will be in form of Cu2O. So it will be a compound of oxygen as an oxide. So this oxide has a color. Number one is that this oxide is solid first. Let me remove this bracket and put this. So it means it is a solid. So if you form a solid, it means this will be a precipitate. So what's going to be the color of that precipitate? So the color of the precipitate is orange. So we're going to have an orange PPT. So let me arrange this very well. I'll put this one here. So we're going to have orange precipitates and bring it down here. So that is why you will have this kind of observation. This is what I want to paste here now. So that is the reason behind this color. This color we have here. So that's the reason behind the color. Let's try and reduce the size. So this is before. This is before the reaction, and this is after the reaction. So the blue color is because of Cu2 plus. The orange color is because of the compound of Cu1 plus. The compound of Cu plus, which is Cu2O, which is solid. So this is going to be precipitate, PPT. So for this reaction to happen, it has to be warm. So we are supposed to warm this solution. I would say warming. This is a sign of heat. So this reaction is positive only to aldehyde. It is negative to carboxylic acid, just like what we have up here. So I can say positive to aldehyde, positive to aldehyde, but negative to negative to ketone. Okay. So this reaction is not about distinguishing between aldehyde and ketone. It is just a test. It's also a form of test, but it's a test that we use to identify a a compound that an organic compound that contain methyl ketone. So when I say methyl ketone, as I said it, this is methyl CH3, an organic compound that contains CH3, and as well C double bond O that bond with something. So this is methyl ketone. So this one can be anything. I put R here. So when I say methyl ketone, so it means this compound. If you know the name of this compound, that would be very nice. This compound CH3 and O. I think I'm wrong by putting O there. CH3H, and that is what's the name of this compound? This is ethanol. So it means ethanol will test positive to triiodomethane test. It will be positive to triiodomethane test because it also contains what do you call it? Methyl ketone. So let me write this one, methyl ketone. So what is the test? How do we carry out the test? So we have to know what is triiodomethane first. Of course, we know triiodomethane. So it's a methane that has 3 iodine atom. That is methane that is substituted with 3 iodine, something like this. So this is triiodomethane. But for this reaction to happen, the triiodomethane must be an alkaline solution. It must be alkaline solution of iodine, and then so that is what we use. The iodine will be an alkaline solution. So from the name, we know, from the title, we said reaction to form. So we are forming triiodomethane, which is iodoform. So it means the product is going to be CHI3. So that's going to be our product. So I will write product here. But what will be our reagent? So the reagent will be an alkaline solution of iodine. So I can write iodine aqueous, but it's going to be in alkaline medium. So and then react it with any compound that contain methyl ketone. So we can just use ethanol as an example, CH3 CHO or CHO. So this is our ethanol. So when we warm this together, so warm, let me arrange this very well. So when we warm our iodine in alkaline medium, that is alkaline solution of iodine, warm it with a compound that contains methyl ketone, we are going to have yellow precipitate. So we have yellow precipitate. I can use yellow, but it will not clear. So I will just say we'll have yellow PPT. That is our observation. So that's what we're going to have. So how does the reaction goes? How does it go for us to have this kind of product? Let's write the equation of the reaction just to show how the reaction happens. So I will just use the just any compound that contains COCH3. So we've seen methyl ketone here already. So this one, and so we have iodine. We have iodine in alkaline medium. So it means we can use potassium iodide. You can use potassium hydroxide or sodium hydroxide as the alkaline medium, CaOH, aqueous. So it means the reaction is going to be kind of halogenation. We want to halogenate this CH3. So that's the reaction. The first reaction is halogenation. We want to add the iodine. We want to substitute the hydrogen atom here with iodine. So therefore the product is going to be RCO CI3. CI3. So you can see that we've substituted the hydrogen with the iodine. So that is the second stage. The last stage where we're going to form the iodoform is alkaline hydrolysis of the product, NaOH. So we call it alkaline hydrolysis. So this product will undergo alkaline hydrolysis. So we're going to have RCO. You know, hydrolysis will give us an ester, but this time around it's going to be salt of an ester because of the sodium that we have over there. So we have Na plus, this is the salt of the ester, plus our iodoform, which is CHI3. So this is our triiodomethane or iodoform. So that is how the reaction happens. It's a two-step reaction. So step one is halogenation. Step two is hydrolysis. So we said earlier that we can use iodomethane test. This iodomethane test, we can use it to test for